Hello, in lesson 8.5 here we're going to look at angles and how they relate to the circles that they're dealing with. So we have already talked about inscribed angles, and we know that an inscribed angle is an angle that has a vertex on the circle and is formed by two chords. And we learned that the inscribed angle is always half of its intercepted arc. So here's the intercepted arc. 25 is half of 50. Another way to say that is the intercepted arc is twice that of the inscribed angle. So you can see those. What this also shows us as we work our way to a bigger and bigger angle 25 degrees, 40 degrees, 60 degrees, and then to a right angle here. Actually, not a right angle, but an angle here. It's still going to hold true even if you have a chord with a tangent line. It's going to be half. This is not a 90-degree angle. It would only be 90 degrees if this was a radius that went to that tangent line. So our first relationship, if the angle is on the circle, the vertex lies on it, so somewhere on the circle, the angle formed, so angle 1, will be half of its intercepted arc. There's some other angle relationships, so there's the one we just mentioned. It's on it, so this angle, let's say angle 2, will be half of its intercepted arc. Now we have two other situations here. First one is when the angle is formed inside the circle. So here we have actually four angles here. We're just going to discuss one of them, but this rule holds true for all of them. So let's say this is angle 1. And so if you look here, this says an angle formed equals half the sum. So the measure of this angle is half the sum of its intercepted arc. Well, it's intercepting this one right here, and its vertical angle's intercepted arc. So let's say this is arc 1. Arc sub 1, and its vertical angle, so the vertical angle is here, its intercepted arc. So plus arc 2. One way I remember this is a plus sign is that when you have this in here, this kind of looks like a plus sign if you turn it sideways. And you'll see what I'm talking about as we get to the next one because it's going to use a minus sign between the two arcs. And then the last theorem, there's three different circumstances you can have. You can have two secant lines intersect outside the circle. So here we'll dealing with outside the circle. Two tangent lines intersect outside the circle. Or a secant line and a tangent line intersect outside the circle. But whatever the case, the angle formed is going to be, so let's say this angle 5 here, the measure of angle 5 is going to be the larger arc. I should say this first, equals 1/2 the larger arc minus the smaller arc. And that's this one here. And these are the arcs that it intercepts, so the arcs that are inside this angle. So over here, angle 6 would be this arc measure, or half of it, half of this one minus this one. Same idea for part C. So we have those three different theorems. I have them written out here at the bottom in this box. If the vertex is on the circle, the angle formed, I just used angle 1, doesn't matter what the name is half its intercepted arc. If it's inside, so we can even put little figures here, this would be on. So there's angle 1. It's going to be half its intercepted arc. Angle 2 is inside. So maybe this is angle 2. It's half the sum, so this one, remember this looks like a plus sign, so plus this one, half of that. And then this one is the vertex is outside. It's actually like the three figures above. So this angle is outside, so you do half the difference, so bigger one minus smaller one. That's what this is. And those are the theorems that you use for working with angles that intersect circles, whether inside the circle, on the circle, or outside the circle.